Good morning, everybody. In this class, we are going to discuss about, first of all, some definitions depending upon solutions. First definition is what? Saturated solution. Which solution is called as saturated solution? The solution containing maximum amount of solute. The solution containing maximum amount of solute dissolved in solvent is called as saturated solution. What is the meaning of maximum amounts? The maximum amount is depends upon the capacity of solvent. How much porous particles are present in that solvent. Depending upon that, total number of solutes can be dissolved in it. That is called as maximum amount. So actual definition is what? Saturated solution. The maximum amount of solute, dissolved in solvent. The maximum amount of solute dissolved in solvent at a given temperature. That is normal temperature. That may be room temperature. At that given temperature, how much particles of solute can be dissolved in that solvent, but that is the maximum. Then it is called as saturated solution. Okay. Second definition is the supersaturated solution. Supersaturated solution. A solution containing greater than equilibrium amount of solute. What? Greater than equilibrium amount of solute is called as supersaturated solution. Actually, how to differentiate saturated and supersaturated? Saturated means what? Depending upon their capacity of the solvents. That solvent containing how much porous particles and solute can be dissolved in its their maximum limit, it indicates saturated. But supersaturated means what? Beyond that, porous particles. So greater than equilibrium. You know the equilibrium term can be studied in ionic equilibrium. Whenever the boundary of solute and solvent, the solute can be mixed in solvent to form the homogeneous solution. That condition is the equilibrium. At any phase, any stage, that is called as supersaturated solution. A solution containing greater than equilibrium, too much than that of the equilibrium, is called as supersaturated solution. Then solubility. Third term is the solubility. The amount of solute present in per unit of volume. Whenever the solution is taken in dm cube or liter in volume, that volume containing per liters of that volume containing how much amount of solutes, is called as solubility. Generally, solubility can measures in 1 liter of solution, 1 dm cube of solution. Therefore, we can indicate what? The solubility, the amount of solute present in per unit volume of saturated solution. Per unit volume of saturated solution is called as solubility. This solubility can expressed in moles per dm cube. This indicates what? In 1 liter of solution, how much moles of solute can be present? So it can indicates moles per dm cube or moles per liter. Moles per liter also. Moles per dm cube means what? Moles per liter. This solubility term is very important because we can calculate how much solute is present in given solution of 1 liter volume. Okay. Then after seeing these terms, saturated, supersaturated and solubility, see the factors affecting for solubility. Which factors are affected for the solubility of solute in solvent for given solutions? Which factors are affecting for that purpose? Generally, the solubility depends upon nature of solute and solvents. What? Nature of solute and solvents. We can form the solutions, that solution containing which type of solute and solvents. Depending upon that solute and solvents, the solubility can be calculated. Second factor is the temperature. When temperature is increased, then solubility is what indicates, or temperature is decreased, solubility can what indicates. So temperature also affected for the solubility. Second factor. And third factor is the pressure. So first of all, see the factors affecting for solubility. Generally, solubility of any solute in a solvent, it depends upon three factors. First factor is the nature of solute and solvent. Second factor, temperature. And third factor is the pressure. See one by one. First factor, that is nature of solute and solvents. How solubility depends upon nature of solute and solvents? First, generally, compounds with similar chemical characters. If the compounds having similar chemical characters are more readily soluble. What? Those compounds can show the same or similar chemical characters are readily soluble than entirely different chemical characters. If the compounds having different chemical characters, entirely different chemical characters. See again this point. Generally, compounds with similar chemical properties can soluble more readily than that of the entirely different chemical characters. Then polar solutes. Polar solutes means what? Those solutes can break up to use the opposite poles. One containing positive ion and another containing negative ion. Means what? The substances after breaking use the ions are called as polar solutes. So the polar solutes dissolves in polar solvents. Polar solute dissolved in polar solvents, because in which solute solvent and solvent interactions having similar magnitudes. Understand this point? Whenever the polar solute dissolved in polar solvent, both are the polars. What is polars? Those substances can break to use the opposite poles, that is positive and negative. When the polar solutes are dissolved in polar solvents, because in which solute solvent and solvent interactions having similar magnitudes. It having the similar magnitudes. For example, NaCl, sodium chloride, that is common salt, dissolves in water. In this example, NaCl and water. Suppose this NaCl and water is the H2O, HOH. Both are the polars. How? Whenever this NaCl breaks up to use the Na plus and Cl minus, that is polar, it is the opposite poles. Solute is polar. Solvent is also polar. When these OH bonds, hydrogen and oxygen bonds are breaks up, then it carries the opposite charges. It carries the opposite charges. Therefore, this example is taken for the polar solute and polar solvents. NaCl dissolves in water, then how it forms the ions? The strong ion dipole interactions. Strong ion dipole interactions, positive and negative. Dipole interaction of Na plus and Cl minus ions with waters. So, this example is concerned with the polar solutes and polar solvents. Then we can also take the non-polar solutes and non-polar solvents. Suppose, example, non-polar organic compound. Non-polar means what? Those substances can break to does not use the ions. Generally, it gives the free radicals. Why? Because it cannot lose or gain the electrons. It gives the free radicals. That's are called as non-polar. Whenever the non-polar organic compounds like cholesterol, which like cholesterol dissolves in non-polar solvent like the benzene. When cholesterol is dissolved in benzene, then generally it does not form the dipole interactions. It can dissolve with each other, but cannot form the ions dipole interactions. Sugars dissolved in water, sugar, carbohydrates that can dissolve in water due to intermolecular hydrogen bonding between sugar and waters. Sugar C6H12O6, that is glucose actually. Sugar C12H22O11, that is price of the glucose. It containing carbon, oxygen and hydrogens. So hydrogen and oxygen can form the intermolecular hydrogen bonding in sugars, and also the water can form the hydrogen bondings. Therefore, sugar can dissolve in waters. It is simple reasons behind it. So sugar can dissolve in water. Sugar can dissolve in water due to intermolecular hydrogen bonding. Which bonding? Intermolecular hydrogen bonding in between sugar and waters. Intra and inter. That's all different words. Intramolecular hydrogen bonding means to what? The hydrogen bonding within that molecule. Within that molecule is called as intra. But here, intermolecular hydrogen bonding is occurs. What about the intermolecular? Intermolecular means to what? To different molecules. One is the sugar that containing hydrogen bonding, and another is the water that also containing hydrogen bonding. When the two different molecules containing hydrogen bonding, then that is called as intermolecular hydrogen bonding. Due to that intermolecular hydrogen bonding, the sugar can dissolve in water. So this is the first factor which is affected for the solubility. Generally we have to take two examples. First of the polar solute and polar solvents. When polar solute can dissolve in polar solvent to form the solubility. Polar solutes and non-polar solvents cannot be taken. It cannot form the solubility. Suppose for example we can take the NaCl common salt and dissolve in benzenes. Then it cannot form the solubility because both are the difference. One is the polar and another is the non-polar. For that purpose, we can take the polar and non-polar. So this is the first factor which is affected for the solubility. Then second factor affected for the solubility. Effect of temperature on solubility. Second factor is the effect of temperature on solubility. How generally temperature is affected on the solubility, or effect of temperature on solubility. The solubility of substance changes with temperature can depends upon enthalpy of solution. Not only temperature, it also affected by the enthalpy of solution. Enthalpy of solution is toward the energy of solution. Whenever the substance is dissolved in solvent, then it is absorbed or evolved. If it is absorbed, then that process is the endothermic. Heat is evolved, then that process is the exothermic. So depending upon that, first point, when substance dissolved in water by absorption of heat, that is endothermic process, then its solubility increases with increasing temperature. Very simple. When substance is dissolved in water and it is absorbed by that substance, then that process is endothermic. It is absorbed. If heat is absorbed by that substance, then its solubility increases with increasing temperature. This indicates that the temperature is totally affected by the solubility of solute in solvents. For example, according to the Le-Chatelier's principle, there is one principle is applicable. The name of scientist, the Le-Chatelier's. According to Le-Chatelier's principle, that factor is affected. KCl dissolved in water, potassium chloride is dissolved in water. Whenever the potassium chloride is dissolved in water, then that potassium chloride can absorb the heat. Potassium chloride absorbs the heat and undergoes endothermic process, and its solubility increases with increasing temperature. That is very simple example. In contrast, that when substance dissolved in water by releasing of heat, releasing is toward the evolution of heat. There are some substances when we can dissolve in water, then it is evolved, like to the detergents or calcium carbonates, calcium chlorides. It is very simple examples. When we can take the detergent and dissolve in water, then it is released, it is evolved. Then that process undergoes the exothermic process. Releasing of heat is the exothermic process. Its solubility decreases with increasing temperature. When the temperature increases, then its solubility decreases because it is evolved, it is released. Then it is totally opposite to the endothermic process. For example, calcium chloride or calcium carbonate dissolved in water, then heat is evolved and which undergoes exothermic process. But its solubility decreases with increasing temperature. There is no direct relation between solubility and any process. Which process? That is endothermic or exothermic. It cannot be indicates the direct relations. But some ionic salts shows variation of solubility with temperature as follows. There are some salts which can show the variations of the solubility with the temperature as follows. Which are that salts? Ionic salts. First, potassium nitrate. Second one is the sodium nitrate. Third one is the sodium bromide, potassium bromide, sodium chloride, and last one is the sodium sulfate. All these salts can show the variations with temperatures. That can be variations indicated this graph. When graph is plotted, solubility of substance versus temperature. This axis can indicate the solubility in moles per dm cube, moles per liter, that is 0, 50, 100, 150, 200 and 250 solubility on this axis. And this axis can indicate the temperature in degrees Celsius, not in Kelvin. It is 0 degrees Celsius, 20, 40, 60, 80 or 100. So how to form the graph of the solubility versus temperature? Sears. These graphs can indicate what? There are some conclusions conclusions depending upon that graph. Conclusions. Which conclusions can occur on these graphs? First, in these graphs there are some salts, see one by one. First, this KCl and NaCl. KCl and NaCl with NaBr. This KCl, NaCl and NaBr. Observe that three salts. Suppose this KCl having the solubility that is lowest than 50, lower than 50 with 0 degree Celsius temperature, lower than 50 at 0 degree Celsius. Then also NaCl having the solubility less than 50 at 0 degree Celsius temperature. Then this NaBr having the solubility in between 150 and 100, that is nearly about 110 at the 0 degree Celsius. But all these three salts, which salts? These salts NaBr, sodium bromide, second one is the KCl and NaCl. KCl and NaCl. All these three salts cannot show the much more variations when the temperature is increases. So this first conclusion is what? First conclusion, the solubilities of first conclusion, solubilities of NaBr, KCl, NaCl, sodium bromide, potassium chloride and sodium chloride changes slightly with temperature. Changes slightly with temperature. There is not a major change. The solubility can change, but very slightly. Suppose the solubility of NaCl at 0 degree Celsius temperature lower than 50, but after the 100 degree Celsius it also lower than 50. Not too much change can be occurs. Changes occur, but that is very slightly change of the solubility. Solubility can changes with temperature, but very slightly. So first conclusion. Then see the second conclusion, solubility of KNO3, NaNO3, KNO3, NaNO3 and KBr. KNO3, NaNO3 and KBr. First, KNO3, see here, KNO3. The solubility of KNO3 at 0 degree Celsius is very lower than that of 50. But with temperature increases, then its solubility increases appreciably fast. When temperature of that KNO3 is 100 degrees Celsius, then its solubility is too much, nearly about the 250. So second conclusion is what? There are some salts like to the KNO3, NaNO3 and KBr. Its solubility can changes appreciably with increase in temperatures. So see the second conclusion, solubilities of KNO3, potassium nitrate, second NaNO3, sodium nitrate and KBr can changes appreciably or increase appreciably with the increase in temperature. So see again, conclusion. First conclusion, solubility of NaBr, KCl, NaCl can changes slightly with increase in temperature. But the solubility of KNO3, NaNO3 and KBr can changes appreciably, fastly with increase in temperature. And last third conclusion with this graph, the solubility of Na2SO4, the solubility of Na2SO4, sodium sulfate, can increases with increasing temperature firstly, then decreases with increasing temperature. This is what it can shows the randomness. First of all, it increase and then decrease. The solubility of sodium sulfate firstly increases and then decreases. That is the exceptional case. First increases and then decreases. So there are thick conclusions of that solubilities. Understand that? First, 3 salts can slightly increases with increasing temperature. Then remaining 3 salts can increases its solubility appreciably fastly with increasing temperature. But only one, sodium sulfate, is the exception. Its solubility first increases then decreases. Understand, this question is very important. This question can ask for the 2 marks in bold pattern. How? Explain effect of temperature on solubility of solid solute in liquid solvent. Remember again the question. Explain the effect of temperature on solubility of solid solute in liquid solvent for 2 marks. At that time you would require all these points with a graph. Then you have to get the 2 marks, otherwise not. These 3 conclusions can indicate half mark for each and half mark for that graph. But this point also important because it can indicate the exothermicity and endothermicity. That is very important questions. Can ask for the 2 marks in bold pattern. So see this graph and gives the conclusion. Okay. So this is the second factor. In next class we will discuss about the remaining factor, that is the pressure, which is required for the solubility of